Good afternoon, my dear students. Previous class we discussed two important compounds of alkali metals, sodium carbonate and sodium chloride. In this class we are going to focus on sodium hydroxide and sodium bicarbonate. So sodium hydroxide, formula of the sodium hydroxide is NaOH. This is the chemical formula composition of sodium hydroxide. Sodium hydroxide is using to purify the bauxite and petroleum refining system. So sodium hydroxide is an important compound in our daily life for the commercial use. So preparing the sodium hydroxide is very essential for the industry uses. For preparing the sodium hydroxide, we have one method. Commercially, we use this method, and name of that method is electrolysis of Brin solution. Electrolysis of Brin solution. So what is the composition of Brin solution is sodium sulfate, calcium sulfate and magnesium chloride. Magnesium chloride. So undergo the electrolysis, Brin solution undergo the electrolysis process. This process name is generally, we can call this commercial name of this process, electrolysis of Brin solution, is Kastner-Keller cell. Kastner-Keller cell. Kastner-Kellner electrolysis process. This is also one of the important question, Kastner-Kellner electrolysis process. So Kastner-Kellner electrolysis process is an electrolysis process. So we are going to use one system for filling electrolytes into it. What is the electrolyte? Is Brin solution. Okay, filling one vessel with the Brin solution. Keep a cathode and anode in this electrolyte. Cathode and anode. We took here cathode as mercury, anode carbon anode. Passing electricity through this solution is getting electrolyzed. Undergo this electrolysis process, the sodium metal is discharged, or it is decomposed from the sodium sulfate, it is splitting into sodium plus and sulfate minus. So all the ion is splitting. What are the ions is present in the Brin solution or decomposes, and this discharge, the sodium is discharged into cathode. What is cathode? Mercury is cathode. So sodium is discharging. Sodium discharge into the cathode rod. Then chlorine, which is evolved from this solution, it is deposited into anode. Okay, so now this sodium is discharged into cathode mercury. So the sodium discharge mercury rod, cathode rod, is generally known as sodium amalgam. Why it is called sodium amalgam? Because it's combined with the mercury. So because of the combination of mercury with the compound is known as sodium amalgam. So sodium amalgam is separated out from the cathode rod is separating out as sodium amalgam, and it is treated with water to give sodium hydroxide. So the reaction involved in the sodium amalgam with water is given below. First, the reaction at cathode is sodium plus, it is dissociated from the sodium sulfate solution, which is discharged into the amalgam. Now the sodium plus combined with electron, that means it is discharged into or deposit into the cathode rod. So it become, the sodium plus is become sodium now. So this is generally known as sodium amalgam because of the deposit of sodium into the mercury rod or the cathode. Then reaction at anode is chlorine is deposited into, or it is evolved as a gas at anode. That means it become Cl. Okay, Cl minus is become Cl, and it is evolved as a gas with releasing electron, with releasing the electrons. So the overall reaction in this electrolysis of Brin solution or Kastner-Kellner reaction is sodium, we can denote here Hg, or in the bracket you can denote it as amalgam. Because no use of this amalgam, we are not going to use this amalgam in this reaction, only separating out this sodium with water or treating this with water. So 2H2O resulting 2NaOH plus 2Hg. So otherwise you can denote here 2NaHg. Means 2Hg is released here. Then the remaining one is hydrogen gas is evolved. This is the overall reaction for preparing sodium hydroxide from the electrolysis of Brin solution or Kastner-Kellner cell electrolysis solution. We have some properties of this sodium hydroxides. Properties. It is a white color. This is white in color. White color, translucent and deliquescent It's a translucent and deliquescent solid, white color solid. So it can melt at 591 Kelvin, and the sodium hydroxide solution is generally sodium hydroxide solution surface is reacted with the carbon dioxide which is present in the in the air, and they form sodium carbonate. So first it can melt. The melting point of this sodium hydroxide is 591 Kelvin. They can form sodium carbonate when the surface sodium hydroxide react with carbon dioxide in atmosphere. Uses of the sodium hydroxide. So sodium hydroxide is generally using as a laboratory reagent. And also using for purifying bauxite and petroleum refinery. Next use, it is using as a textile industry to mercerizing cotton fibers. Next use, this is used to manufacture soap, paper, artificial silk, and many number of chemicals. So soap, paper, these all are important use. Soap, paper, artificial silks, and some chemicals. These are the uses and all about sodium hydroxide. Next compound, sodium bicarbonate. So the another name of this sodium bicarbonate is baking soda. For using this in the bakeries for baking cakes and pastries. Because of this use, it is called baking soda. And when it is decomposed on heating, they generate some or releasing the carbon dioxide. From the sodium bicarbonate, it is releasing the carbon dioxide. Because of releasing amount of carbon dioxide, it can make bubbles into the cake. So we can see some holes or some bubble is generated into the cake. It's only because of the baking soda added into it, and the baking soda is releasing the carbon dioxide. Because of this carbon dioxide gas into the cake, it is produce the bubbles in between in the cake or fluffy one. Okay, so because of this these cakes and pastries are become more fluffy and more light and soft. This baking soda is usually prepared for the from the saturated solution of sodium carbonate with the carbon dioxide. solution of sodium carbonate with carbon dioxide excess. You learned this is in the Sawley process, sodium carbonate. So that sodium carbonate is reacting with the carbon dioxide to form the sodium bicarbonate, that means baking soda. So this is one white crystalline powder, the sodium bicarbonate, and it is a less soluble one. If you dissolve this in the water, you will get the precipitate out of this sodium bicarbonate into that water. So it is a less soluble compound. So what are the uses involved in this baking soda? Mainly we use this ingredient for baking cakes. That means in the bakery we use this one. And sodium hydroxide is using as a mild sodium hydrogen carbonate, that means sodium bicarbonate is using as a mild antiseptic for the skin infection. We can use this as a mild antiseptic, and also using this sodium bicarbonate into the fire extinguisher, that means to use this fire extinguisher solution to off the fire, to reducing the fire. These are the uses of sodium bicarbonate. Next topic from this alkali metal is biological importance of sodium and potassium. Sodium and potassium. Generally we say this is biological form of sodium and potassium in the human being. It is a sodium potassium pump, which is shown in this figure, sodium and potassium pump, how it is reacting in our body. This sodium and potassium are existing in our body like ions, sodium ion and potassium monovalent ion. Potassium and sodium monovalent ions. They represent here in the biological fluids. So the fluids which is in our body, it is combined with that biological fluid as sodium plus and potassium plus. That means the monovalent of sodium and potassium ion, and it is playing an important role in our body to maintenance the iron balance, to balancing this iron in our blood. Okay, so for using this sodium and potassium monovalent to balancing iron. Okay, iron balance or balance. Iron balancing and nerve impulse conduction, and also nerve impulse conduction. So nerve impulse and conduction is a important action is undergo in our body. So this is important for doing the action of the body by the nerves. So it is conducting the nerve impulses to in our body. In 70 kg of a man contain 90 grams of monovalent sodium and 170 gram of monovalent potassium. But the body combine 5 grams of iron and 0.06 gram of copper. Generally sodium ion found in the outside of the cell and it is located in the blood plasma. So it is an interstitial fluid which is surrounded by the surrounds the cell. So it is also sodium is present in that interstitial fluid blood plasma. So the cell is surrounded by the sodium containing blood plasma, that fluid is present outside of the cell, and it is important one to transmitting the nerve signal to the cell, and also it is regulating the flow of water. So across the cell membranes, how it is from the inside to outside, outside to inside, the water transmission regulating is it's regulating by the sodium ion, and also its transport sugars and amino acid into the cell. It is transmitting the sugar and amino acids. Sodium and potassium both are reacting chemically as the same, but the quantity is present in our body is different. So you can see the different of quantity of potassium and sodium in our body. So because of this different quantity, they can penetrate the cell membrane. So they also have the ability, potassium also have the ability to penetrate the cell membrane, and they activate the enzymes. Some enzymes, they have the efficiency to activate enzymes. So because of this efficiency of activating enzyme and penetrating into the cell membrane, this will become the most abundant cation within the cell fluid. So they can activate many enzymes and participating into the oxidation of glucose to prepare this ATP, adenine triphosphate, with sodium. So they are responsible for transmitting the nerve signals. And sodium and potassium pump is playing the important role for transmitting the nerve signals. So this is the important use of this sodium and potassium pump in our body. That means the biological importance of sodium and potassium pump. So today's topic over. Study this sodium and potassium pump, or importance, the biological importance of sodium and potassium pump. It is an important question. So study well. Okay students, thank you.